We already talked about sequential and concurrent assignments, but what is the actual difference? Hello and welcome. In the last video tutorial, we had a look into using processes to implement digital circuits. In contrast to signals assignments inside a process, which are evaluated in a sequential way, assignments outside are executed in parallel. Let's have a look at a simple example. Here you can see the VHDL code for a simple flip-flop with a clock, a reset, a data and an enable input. The output signal is named Q. Down below you can see the architecture description where 3 signals are defined at the beginning. The body of the architectural description includes 2 concurrent signal assignments and a process which is triggered on the clock and the reset signal. This implementation is a good example to showcase the differences between concurrent and sequential signal assignments. The first 2 lines of the architectural description show the assignment of Q and temp3. As you can see, temp3 is set by temp2 and assigned to Q. Since these are concurrent statements, they happen immediately. Hence, we achieve the same behavior when we would replace those 2 lines just by assigning signal temp2 to Q. Okay, so now let's move on to the process of our flip-flop. In the event of a rising clock edge, which is the condition for the else-if, the 2 signals temp1 and temp2 are set. The input data D is assigned to temp1. Temp2 instead is set to the value of temp1. In first place, this looks similar to the concurrent signal assignments at the beginning of the architectural description of our flip-flop. However, in this case, the assignments happen inside a process. What effect does it have on the behavior of the design? First, let's remind ourselves about how these processes work. The signal evaluation is always done at the end of the process. So even though D is assigned to temp1 before temp1 is assigned to temp2 in the code, temp1 still has the same value when assigned to temp2. Consequently, this implementation adds a delay of at least 1 clock cycle for the data to pass the flip-flop from the input to the output. Here you can see the result of synthesizing the design. I generated it using Vivado, the tool that you will also be using in our course to synthesize your models. As expected, not only 1 flip-flop is used for implementing the behavior of the model, but 2. Let's sum it up. Inside a process, the signal values are updated at its end. In contrast, variables are updated immediately. So if you implement such sequential signal or variable assignments, keep this in mind and you will avoid a very common timing error in your design.